What's the periodic table? Have you ever wondered how scientists keep track of all the different elements that make up everything in the universe?
The periodic table is like a giant chart that lists all the known elements in the universe. It's a comprehensive guide that helps scientists, students and educators understand the building blocks of matter. Elements are the basic building blocks of everything around us. They are pure substances that cannot be broken down into simpler substances by chemical means. Think of elements like ingredients in a recipe. Just as you need flour, sugar and eggs to bake a cake, you need elements like hydrogen, oxygen and carbon to create water, air and living organisms. Just like you need different ingredients to make a cake, different elements combine to form everything we see and touch. For example, water is made from hydrogen and oxygen, and salt is made from sodium and chlorine. The periodic table is important because it organizes these elements in a specific way. Each element is placed in a particular location based on its atomic number, which is the number of protons in its nucleus. This organization helps us understand the properties of elements and how they will react with each other. For instance, elements in the same column or group often have similar chemical properties. It's a bit like having a map of all the ingredients in the world and knowing how to use them. The periodic table not only tells us what elements exist, but also provides valuable information about their characteristics, such as their atomic mass, electron configuration, and reactivity. By studying the periodic table, scientists can predict how elements will behave in different situations, which is crucial for everything from creating new materials to understanding biological processes. So next time you see a periodic table, remember that it's not just a chart. It's a powerful tool that helps us unlock the secrets of the universe, one element at a time. Whether you're a student, a scientist, or just someone curious about the world, the periodic table is an essential resource that brings order to the complexity of chemistry. It's a testament to human ingenuity and our quest to understand the fundamental nature of everything around us. So, dive in and explore the fascinating world of elements.
Mendeleev's masterpiece.
The periodic table wasn't always around. A brilliant Russian chemist named Dmitry Mendeleev came up with the idea back in 1869. Mendeleev noticed patterns in the properties of known elements. He cleverly arranged the elements by their atomic weight, which is like their weight, and grouped similar elements together. The amazing thing is that Mendeleev even left gaps for elements that hadn't been discovered yet. He accurately predicted their properties, and guess what? He was right.
Arranging the elements.
Today, the periodic table is arranged by atomic number, which is the number of protons in an atom's nucleus. This number determines the element's identity. Think of it like an element's fingerprint. The periodic table is organized into rows called periods and columns called groups. Elements in the same group share similar chemical properties because they have the same number of valence electrons, which are the electrons in the outermost shell of an atom.
Metals, nonmetals, and metalloids.
Elements on the periodic table can be broadly classified into three main categories: metals, nonmetals, and metalloids. Each of these categories has distinct characteristics and properties that make them unique and useful in various applications. Metals are typically shiny, malleable, and good conductors of heat and electricity. This means they can be hammered into thin sheets or drawn into wires without breaking. Their ability to conduct heat and electricity makes them indispensable in electrical wiring and cookware. Think of everyday objects like copper wires or aluminum foil. These items are not only practical, but also demonstrate the versatility and importance of metals in our daily lives. From the cars we drive to the buildings we live in, metals play a crucial role. Non-metals, on the other hand, are usually dull, brittle, and poor conductors. They lack the luster of metals and tend to break or shatter rather than bend. This makes them less suitable for structural applications, but useful in other ways. They are often gases at room temperature, like oxygen and nitrogen. These gases are essential for life in various industrial processes. For instance, oxygen is crucial for respiration, while nitrogen is used in fertilizers to enhance plant growth. Metalloids, as their name suggests, have properties that fall somewhere in between metals and non-metals. They exhibit a mix of metallic and non-metallic characteristics, making them unique and versatile. They can be shiny or dull and have intermediate conductivity. This means they can conduct electricity better than non-metals, but not as well as metals. This intermediate conductivity is particularly useful in the electronics industry. Silicon used in computer chips is a classic example of a metalloid. Its ability to conduct electricity under certain conditions makes it ideal for use in semiconductors, which are the backbone of modern electronic devices. From smartphones to computers, silicon's role is indispensable in our technology-driven world. Section 5. Exploring the groups, a sneak peek. Let's take a quick tour of some interesting groups on the periodic table.
Group 1, the alkali metals, are highly reactive metals that readily form compounds with other elements.
Group 2, the alkaline earth metals, are also reactive but not as much as their alkali metal neighbors.
Group 17, the halogens, are highly reactive nonmetals that love to form salts with metals.
And finally, Group 18, the noble gases, are the loners of the periodic table. They are very stable and rarely react with other elements. Section 6. Hidden patterns, unraveling the periodic trends. The beauty of the periodic table lies in its ability to reveal patterns in the properties of elements.
As you move across a period or down a group, you'll notice trends in properties like atomic radius, ionization energy, and electronegativity.
For instance, atomic radius generally increases as you move down a group because electrons occupy higher energy levels farther from the nucleus.
Understanding these trends helps us predict how elements will behave in chemical reactions.
Section 7. Fun facts from the table. Did you know that the lightest element on the periodic table is hydrogen, which makes up about 75% of the universe's mass?
Or that the rarest naturally occurring element on Earth is astatine, with less than 1 gram estimated to exist in the Earth's crust at any given time.
And here's a cool one. Mercury is the only metal that's a liquid at room temperature.
These fun facts show that the periodic table is full of surprises and wonders waiting to be discovered.
Section 8, the periodic table in our daily lives. The periodic table is not just for scientists in labs, it's relevant to our daily lives in countless ways.
Elements from the periodic table are found in everything from the food we eat to the smartphones we use.
For example, sodium and chlorine, two elements from opposite sides of the periodic table, come together to form sodium chloride, which is common table salt.
The lithium in our rechargeable batteries, the iron in our buildings, and the oxygen we breathe, they all come from the periodic table.
Section 9. Beyond the basics. A world of chemistry awaits. The periodic table is the foundation for understanding the vast and fascinating world of chemistry.
It's the starting point for exploring chemical reactions, molecular structures, and the properties of matter.
As you delve deeper into the world of chemistry, you'll discover how elements combine to form compounds, the different types of chemical bonds, and the principles that govern chemical reactions.
The possibilities for exploration are endless.
Section 10. Conclusion. The periodic table, your guide to the elements. The periodic table is an incredible tool that unlocks the secrets of the elements and their behavior. It organizes all known elements in a way that reveals their properties and relationships to one another. This arrangement allows scientists to predict how elements will react with each other, making it an essential resource in the field of chemistry.
From its humble beginnings in Mendeleev's mind to its modern-day significance, the periodic table has evolved significantly. Mendeleev's initial design was based on the atomic weights of elements, but today it is organized by atomic number, which provides a clearer understanding of the element's properties. The periodic table continues to be an indispensable tool for scientists, students, and educators. It serves as a reference point for understanding chemical reactions, bonding, and the properties of elements. In classrooms around the world, it is a fundamental part of the curriculum, helping students grasp the basics of chemistry. And anyone curious about the building blocks of our universe can find answers within its rows and columns. The periodic table is not just for scientists, it is for anyone who wants to understand the natural world.
So the next time you encounter the periodic table, take a moment to appreciate its significance. It is a culmination of centuries of scientific discovery and collaboration. Remember that it's not just a chart on a classroom wall. It is a powerful tool that helps us understand the elements that make up our world and beyond. Each element has its own story, and the periodic table is the key to unlocking those stories. It's a gateway to understanding the elements that make up our world and beyond. Whether you're a student, a scientist, or just someone with a curious mind, the periodic table is your guide to the elements and their fascinating properties.